Hello friends, I welcome you in lecture number 15 on Laplace transform. In this lecture also we will discuss how to find out Laplace transform if our function is divided by t. And this question was asked in GTU summer 2014 exam. Here given function is sin omega t divided by t, where omega is constant, and we are asked to find out Laplace transform of this function sin omega t divided by t, and we know that this is given by improper integral with limits from s to infinity, and we have to integrate Laplace transform of sin omega t with respect to s, and we know that Laplace transform of sin omega t is omega divided by s square plus omega square. Integral is with respect to s. Now this is improper integral of first type, so we can replace upper limit by some another variable, say b, and then we take limit b tending to infinity, and integral of omega divided by s square plus omega square. Integral is with respect to s. So we know the formula for integral of this type of function. We have ready-made formula for the integral of 1 over x square plus a square with respect to x. This integral is 1 by a times tan inverse x by a, and if we have a multiplied here, then we will have tan inverse x by a. So we can compare with this. Instead of x we have variable s, instead of constant a we have constant omega. So integral of this is tan inverse s divided by omega, and limits of integral are from s to b. Now this is equal to limit b tending to infinity. Upper limit is s equal to b, so we write tan inverse b divided by omega minus lower limit is s itself, tan inverse s by omega as it is. Now we find out limit of this bracket as b tending to infinity. In second term there is no b, so limit of tan inverse s by omega as b tending to infinity will be tan inverse s by omega. So this we can write as limit b tending to infinity of tan inverse b divided by omega minus limit of tan inverse s by omega with respect to b is tan inverse s by omega. Now if we take b tending to infinity here, we will have tan inverse infinity divided by omega, and suppose omega is positive, this will be tan inverse infinity. So here we can assume that omega is positive, where omega is a positive constant. If it is not positive, we have to consider two cases. Omega is positive, then we have tan inverse infinity, and omega is negative, then we will have tan inverse of minus infinity. But here we assume that omega is positive, so this is going to be tan inverse infinity. Because omega is positive, infinity by omega is infinity, minus tan inverse s divided by omega, and here we write that because omega is positive. And we know that if we find out value of tan function at pi by 2, then it is sin pi by 2 divided by cos pi by 2. Sin pi by 2 is 1, cos pi by 2 is 0, and this is infinity. Therefore if we take inverse function, then tan inverse infinity is pi by 2. So we can write tan inverse infinity equal to pi by 2, and minus tan inverse of s divided by omega. And if we recall the property of addition of tan inverse and cot inverse, we know that tan inverse x plus cot inverse x is pi by 2. So if we have pi by 2 minus tan inverse x, we will have cot inverse x, and instead of x here angle is s by omega. So we can replace this by tan inverse s by omega using this property. So we have obtained Laplace transform of sin omega t, which is divided by t, and Laplace transform we have obtained is cot inverse s divided by omega. So we can easily obtain Laplace transform of this type of functions using the formula of division by t. So we are using this formula from last several lectures. If our function is divided by t, then Laplace transform is given by improper integral of Laplace transform of f of t with respect to s. Here f of t is sin omega t, so we have integrated Laplace transform of sin omega t with respect to s, and we have obtained that Laplace transform of sin omega t by t is cot inverse s by omega. Instead of omega, they can give you particular value. Suppose we are asked to find out Laplace transform of sin t by t, then if we compare with omega t, here omega will be 1. So in this case Laplace transform will be cot inverse of s. Suppose omega is 2, suppose they ask to find out Laplace transform of sin 2t divided by t, then here we put omega equal to 2, and our Laplace transform will be cot inverse of s divided by 2. So either they can ask you arbitrary constant omega t, or they can give particular values of omega. In all the cases we are just applying this formula, Laplace transform of division by t. So we just have to obtain Laplace transform of this function and then integrate with respect to s, and be careful, this is improper integral. So we use the definition of improper integral. We replace upper limit by some another variable, and then we consider limit as b tending to infinity. Instead of b, you can use your own variable also. Suppose we use t here, then here we will write t tending to infinity. If we are writing a, we will write a tending to infinity. So that is our choice. We can choose the variable as we wish. So this is all about this session. I hope you like it. Thank you very much.